Well, hello Internet, and welcome to part 4 of my linear algebra tutorial series. In this part of the tutorial, we're going to talk about multiplying matrices. We are going to also talk about identity and inverses, as well as provide a real-world example of why this stuff is even useful. And I have a lot to do, so let's get into it. Okay, so we're going to start off here just simply covering how a scalar multiplication works whenever you're working with matrices. So let's say you have 1, 2, 3, and 4, and this is multiplied times a scalar of 3. Well, that is going to simply give you 3, 6, 9, and 12. So there you go. That is how you multiply a scalar times a matrice. Now, whenever you want to multiply matrices times matrices, there's a couple rules you have to be aware of. First off, the number of columns in the first matrice must equal the number of rows in the second. So, for example, if you have a 3 by 2 matrice, you can multiply it times a 2 by 1, a 2 by 2, a 2 by 3, and so forth and so on. And you can see here that if you put the dimensions together, that the numbers in the middle will be equal. So if you have 2 and 2 right there. And what we are going to do whenever we multiply matrices is we are basically using the dot product. So for example, let's say you have x11, x12, x21, and x22. Of course, the 2 represents rows, or the first number represents rows, the second refers to columns. And you multiply that times this double matrice. The way this is going to be solved is you're going to take x11 times w11 and add it to x12 or x12 times w21, and then underneath you'll have x21 times, again, w11 plus x22 times w21, and then to get the value in the upper right hand corner, this will be x11 again times w12 plus x12 times w22, and I think you can see how you are basically repeating the actions over and over again, times w22. And that is how we can perform multiplication between matrices. So let's see an example here, and then I'll show you a real-world example of why this is useful. So let's say you have 1, 2, 3, 4 multiplied times 5, 6, 7, and 8. What we're going to do here is get the 1 times our 5 plus 2 times our 7, and then 3 times 5 plus 4 times 7, and 1 times 6 plus 2 times 8, and 3 times 6 plus 4 times 8. And of course, this is going to give us a final result of 19, 22, 43, and 50. And there you go. But you say to yourself, well, how is this at all useful? Well, let me show you. So let's say, for example, that we have an office. We have 2 offices. So office 1 and office 2. And these 2 offices are going to be ordering different office supplies. So they want a certain number of pens, they want a certain number of pencils, and a certain number of notepads. And we know that specifically Office 1 wants 10 pens, they want 5 pencils, and they want 9 notepads, while Office 2 wants 12 pens, 4 pencils, and 8 notepads. And this is going to be packs of pens and pencils, just to be specific. Well, What we can do is we can multiply a list of items times the cost per item matrix, which we're going to create right now, and get a total cost matrix, which is really, interesting. So this is our total cost matrix. So we'll have our pens, pencils, and notepads. Let's say the pens cost $2 for a pack, the pencils cost $4 for a pack, and a pack of notepads costs $2. So what I can do is I can take our matrix, which is going to be the request for items. So this will be 10, 5, and 9, and 12, 4, and 8. And I can multiply it times 2, 4, and 2. And if I do that, we will get a new matrix just by going 10 times 2 plus 5 times 4 plus 9 times 2 and 12 times 2 plus 4 times 4 plus 8 times 2. And this is going to give us our total cost for both offices, which is going to be 58 and 56. So there you go. That is just one example of useful things you can do with matrices, and more specifically, multiplying matrices. And that brings us to identity matrices, which you've already seen before. And basically an identity matrix is just a matrix that when multiplied times another returns the same matrix. And they are always square, and they are always going to be of this form. So 1 and 1 and 0 and 0. As you can see, the 1s go in the diagonal, and everywhere else you get zeros. You have seen these before. Now they are normally going to be abbreviated like I2, and because they're always square, of course, this means that this is a 2 by 2 matrix, but we just abbreviate it. And let's see exactly how they work. So we'll have 1, 2, 3, and 4. And if we multiply that times an identity matrix, which is going to be 1, 0, 0, 1, this is going to give us a result of 1 times 1 plus 2 times 0, 3 times 1 plus 4 times 0, 1 times 0 plus 2 times 1, 3 times 0 plus 4 times 1. And I think you can see why this is going to give us the exact same matrix, because they basically zero out anything that's different. And there you go, you get the exact same matrix. But you may ask yourself, well, why do all identity matrices have to be square? Well, let's use an example. So we'll have our identity matrix here times, and we'll just throw in a random matrix. So 3, 2, 1, 2, 2, 4. Well, first off, I must have the same number of columns in the first matrix as rows in the second. So that tells us that if we're multiplying this, I must be something by 3. All right, so we must have the same number of columns in the first matrix as rows in the second. So we have 1, 2, 3. So that means we must have 3 columns in our identity matrix. On top of that, we know that the resulting matrix is going to have 3 rows. So that makes it 3 by 3. Okay? And that's going to be true for any identity matrix. And that brings us to inverse matrices. Now, like numbers have reciprocals, a square matrix has an inverse matrix that whenever you multiply times it, it's going to provide an identity matrix. It's very important to know, however, that only square matrices have inverses, and if you have a matrix A, the inverse matrix is going to be labeled with a -1 in the exponent as a symbol. And to find the inverse, all you're going to do is augment the matrix with an identity matrix. So let me show you here exactly an example. Let's say that you have a matrix which is going to be 2, 2, 3, and 2. And you want to find the inverse. So what you're going to do is augment it with an identity matrix and turn the left side into an identity matrix, and that will give you your inverse. So how are we going to do this? Well, the very first thing we're going to do is we're going to take R1 and divide it by 2. And if we do that, that is going to give us 1, 1. And you're going to carry this over into our identity matrix. So this will be 1/2 and 0. 3, 2, 0, 1. Then what are we going to do? Well, I need to turn the bottom left-hand corner of this matrix into a 0. So I'm going to take R1 times the negative of the value in A21, add it to the value in R2, and store it back inside of R2. So let's do that. This is going to end up being 1 times negative 3 plus 3. 1 times negative 3 plus 2. 1/2 times negative 3 plus 0. And 0 times negative 3 plus 1. This, of course, stays 1. This, of course, stays 1. This is going to stay 1/2. And this is going to be a 0. And if we do all of that, what is that going to give us? That's going to give us a value of 1, another 1, a 1/2, a 0, a 0, a negative 1, a negative 3 over 2, and a 1. And in the upcoming videos, of course, I will be going in and showing you how real-world ways of working with this. Okay, next thing what we need to do is I want to convert my negative 1 into a 1. So how I'm going to do that is I'm going to divide every one of those rows by negative 1. And if I do that, I will get 1, 0. This becomes a 1 as well. This is a 1. This is still going to be a 1/2. This is going to be 3 over 2, 0, and negative 1. All right, so now all I need to do is turn the 1 up here into a 0, and we are finished. So how will I do that? Well, I'm going to go get R2 times the negative value of whatever is in A12, add it to R1, and put it in row 1. So let's do it. So this is going to be 1. This is going to remain 0. This is going to be 1 times negative 1 plus 1. This, of course, stays 1. Then we're going to have 3 over 2 times negative 1 plus 1/2. This remains 3 over 2. And then finally we have negative 1 times negative 1 plus 0. And this remains negative 1. And whenever we go and fill out all of those calculations, what we end up with is this is an identity matrix now. And what is left behind is our inverse matrix. And if we go and test this out, what we will get is we'll get 2, 2, 3, 2 times negative 1, 3 over 2, 1, and negative 1. If those are multiplied together, that is going to give us 2 times negative 1 plus 2 times 3 over 2, and 2 times 1 plus 2 times negative 1, 3, negative 1 plus 2, 3 over 2, 3 times 1 plus 2, negative 1. And if we multiply all those out, we are going to get a final matrix that will be an identity matrix. And there you go. So you learned a whole bunch of things about linear algebra in this tutorial, and more is coming. And like always, please leave your questions and comments down below. Otherwise, till next time.